Well, this time also we will solve some series and parallel circuit. Here the main purpose is to study their behavior. That's why we have taken one resistance small and one resistance small. This is R1, that is 1 ohm, and this resistance is R2, that is 100 ohm. And in this configuration we have to study more about the series circuit. So let us start. Here the voltage connected is 30 volt DC source, and for this let the current that will flow through this circuit is I. So now what is the equivalent resistance of these two resistances in series? Let this be Req. So is connected to this 30 volt supply, and R equivalent is the equivalent of R1 and R2 which are in series. So you know that Req, that is equal to R1 plus R2, that is equal to 1 plus 100, that is equal to 101 ohm. So the equivalent resistance is 101 ohm. That is the simple addition of these two resistances. So the equivalent resistance is 101 ohm. Now let us find the current that will flow in this circuit. This current is same in the equivalent circuit. So I is 30 divided by Req. I is equal to 30 volt divided by Req. Req is 101 ohm. That is equal to how much? Let us calculate. That is 0.297. This much ampere, 0.297 ampere. So this current will flow in the equivalent circuit. So this current is same, that is equal to 0.297 ampere. Now let us find the voltage drop across these two resistances. Let this voltage drop is V1 and the voltage drop across R2 is V2. So how to find voltage drop across this resistance? Here also we will again apply the Ohm's law. Here V1 is equal to I R1. I we have already got it. So V1 is equal to I R1. I is how much? 0.297. 0.297 ampere into R1. R1 is 1 ohm. 1 ohm. So it is 0.297 volts. Similarly V2 is equal to I R2, that is equal to 0.297 ampere into R2. R2 is 100 ohm. So we will get how much? 29.7 volts. Okay. Now from this finding we can see that V1 is very less, that is only 0.297 volt, and V2 is 29.7 volt. Now you can see that R1 is 1 ohm and R2 is 100 ohm. So R1 is very less, so the voltage across R1 is V1, that is also less, and voltage across R2, that is V2, that is quite high. Now let us find V1 divided by V2, this ratio. V1 divided by V2 is equal to 0.297 divided by 29.7, that is equal to 1 divided by 100. Okay. Now if we will divide V1 divided by V2 from this equation, it will be I R1 divided by I R2. So cancelling I, that is equal to R1 divided by R2. What we are getting here? V1 divided by V2 is equal to 1 divided by 100. This is very important. So you should remember that when the resistances are connected in series, the voltage across them are in proportion to the resistances. That is the important concept here. Okay. And if this resistance will be even more smaller, That means suppose R1 is equal to 0.1 ohm and R2 is equal to 100 ohm. Then what will be the voltage drop V1 and V2? Voltage drop across R1 will be how much? We will take the ratio V1 divided by V2 will be equal to R1 divided by R2, that is 0.1 divided by 100, that is 1 by 1000. Then you can see that this voltage will be 1000 times of the voltage drop across this if R1 will be 0.1 ohm. So when this resistance will be small enough, you can easily ignore this resistance and take this resistance, and you can also see that R equivalent is equal to 100 plus, if it will be very less, it will be 100 plus 0.1, that means 100.1, and it will be closer to how much? 30 divided by 100, that is 0.3 ampere, if this is very small. Now let us solve this circuit just like the series connection. Here these two resistances are connected in parallel. The resistance values are the same as it was in case of series resistance. R1 is 1 ohm and R2 is 100 ohm, and these two are connected across a DC voltage source of 30 volt. So first we have to calculate the equivalent of these two resistances which are in parallel. Let R EQ is the equivalent of these two. So you can find this equivalent from the formula that we know. 1 divided by R equivalent, that is equal to 1 divided by R1 plus 1 divided by R2. R2 is 100 ohm. So we will get 1 plus 0.01. So R equivalent is equal to, this is how much? This is equal to 1.01, and R equivalent, that is equal to 1 divided by 1.01, that is how much? That is coming around 0.99 ohm. 0.99 ohm. Now we can solve this circuit. We have got this as 0.99 ohm. Now this is a simple Ohm's law circuit. So I is equal to 30 divided by R equivalent. So I is equal to 30 volt divided by R equivalent, that is how much? 0.99 ohm. That is how much? We have calculated that as 30.30, that is 30. So I is 30.30 ampere. Now this current I in the main branch, it will divide between these two branches, I1 and I2. Now we have to calculate I1 and I2. What should be their values? Now you can see that these two resistances, they are connected across this voltage source directly. So voltage across this resistance R1 is 30 volt. Also the voltage across this resistance R2 is 30 volt. So you can find out I1 applying the Ohm's law again to these resistances independently. I1 is equal to voltage across this divided by this resistance, that is 30 volt divided by 1 ohm, that is 30 ampere. And I2 will be how much? That is the same voltage, 30 volt across R2 also, 30 volt divided by 100 ohm, that is equal to 0.30 ampere. Now you can see that I1 plus I2 is equal to how much? It is 30 plus 0.30, that is equal to 30.30 ampere. This is I. You can see I is 30.30 ampere. This I is same as this I, that is 30.30 ampere. Now this current will divide between I1 and I2. That is what we are getting here. Now suppose we will find the ratio, in which ratio these currents I1 and I2 we are getting. That is I1 is how much? I1 is equal to V divided by R1, V divided by R1 divided by I2. I2 is how much? That is V divided by R2. That what we have got, V divided by R1, V divided by R2, that is equal to R2 divided by R1. So numerically also you can find here I1 divided by I2, how much we have got? 30 divided by 30 ampere divided by 0.30 ampere. It is how much? It is 100. So I1 is 100 times of I2. Here also you can see I1 is R2 divided by R1 is 100 by 1. So I1 is 100 times of I2. Because the resistance, one having the low resistance, the current will be more, and one having high resistance, the current will be less. Here R2 is 100 times of R1, that's why I1 is 100 times of I2. Also you can see that R equivalent, that is 0.99. This R equivalent is less than both R1 and R2. Moreover, this current I, main branch current, is 30.30 ampere. In case of series, I is 0.297 ampere, very less in comparison to parallel circuit. Here in case of parallel circuit, the sum of this current is equal to the main branch current I, but in case of series, the sum of the voltages, that is equal to the source voltage, 30 volt. So now you can see that this resistance we have taken it only 1 ohm, and this resistance 100 ohm, that we have taken purposefully to show you the behavior of the circuit. You can see that this resistance is 100 times of this, so this current is 100 times of this one. But in case of series connection, you can see that this voltage is 100 times of this. You can see from this V2 is 29.7 and V1 is 0.297. So V2 is 100 times of V1. And if this resistance will be even smaller, that will be, suppose it is 0.1 ohm, then this voltage will be 1000 times of this. So if this resistance will be small and very very small, 0.001, so this voltage across this resistance can be neglected, and almost this voltage V2 will almost approach 30 volt. And in case of parallel connection, if this resistance will be very high, then almost all the current will pass through this. It is as if this 1 ohm resistance is connected to this 30 volt. And moreover, one thing you can note down, that you see the R equivalent, that is 0.99 ohm. It is less than both the resistances. And if this resistance will be much more, then their equivalent will approach 1 ohm. So here this gap is very high between R1 and R2, so R equivalent is 0.99 ohm. Okay, so we'll discuss more next time.